We are now in part 2 of IPv4 addresses. We will start the session with the outcomes. Upon the completion of this session, the learner will be able to understand the conversion of IP address from dotted decimal to binary and vice versa. So we are going to ultimately focus on the conversion of IPv4 address from dotted decimal to binary and from binary to dotted decimal. Let's start with the conversion process. In order to convert the decimal to binary or from binary to decimal of the IPv4 address, we are going to follow this scheme. We need to remember these 8 digits. Why? IPv4 addresses are 32 bits long. How these 32 bits are organized? These 32 bits are organized in 4 octets. So every octet is going to be with 8 bits. These are the 8 digits which are going to be used for both the conversion. I will give you an easy way to remember these 8 digits. Just start with 1. Just multiply 1 with 2, we will get the next digit, that is 2. Just multiply this with 2, we will get the next digit, which is 4. Just multiply 4 with 2, we will get 8. 8 into 2 is 16, 16 into 2 is 32, 32 into 2 it is 64, and 64 into 2 is 128. We need to stop the sequence up to this. Why? Because we got 8 digits. With the help of these 8 digits, we can get 8 bits easily. In other words, it is simply 2 power 0. That is, this is 2 power 0, this is 2 power 1, this is 2 power 2, and up to 2 power 7. Since it is starting with 2 power 0, we need to end with 2 power 7, so that we will be getting the 8 bits. Using this technique, we can convert the dotted decimal to binary and the binary to dotted decimal. Let's start with the first example. Example number 1. Convert the IPv4 address from binary to dotted decimal notation. And we are given with the binary notation. So we are required to convert this into dotted decimal. So the solution involves the methodology which I had projected. So I have brought in that table. Now how to convert the given binary into dotted decimal? We know IPv4 addresses are of 4 octets, that is 32 bits. So let's start with the first octet, that is this octet, that is 1, 6 zeros, 1. 8 bits we have. Just we are going to take this entire 8 bits and just like that we are going to place in this place. So just observe, I am going to place this 1, 6 zeros and 1 just like this, 1, 6 zeros and 1. And that's it. We are at the verge of the conversion of the binary to dotted decimal of the first octet. It is very simple, Then what is the decimal value? The decimal value is the summation of the places where we have 1. So where we have 1 against 128 and we have 1 against 1. So we are going to take only these 2 places because in these 2 places only we have the binary ones. Can you notice the binary ones? So the answer is 128 plus 1. 128 plus 1 is 129. The first octet is 129. Let's move on to the next octet. So what we are going to do? We are going to take this and just like that we are going to place it. And where and all we have 1? We have 1 against 8, 2 and 1. So the decimal notation is 8 plus 2 plus 1, which is this 8 plus 2 plus 1. So 8 plus 2 plus 1 is 11. So the second octet is 11. Already we know this is 129. Now this is 11. Let's move on to the third octet. In the third octet, just place this here. And where and all we have 1? We have 1 against 64, 8, 2 and 1. So 64 plus 8 plus 2 plus 1 is 75. Let's now move on to the last octet, which is 111011111. So I'm gonna place 111011111. Where and all we have 1? We have 1 in 7 places. So we are going to take the 7 places, that is 128 plus 64 plus 32 plus 8 plus 4 plus 2 plus 1, which is 239. And the last octet is 239. We can also solve this in other way. When all bits are 1, what is the maximum number we will get? We know when all 8 bits are 1 in an IP address, we will be getting 255. So 255, we will consider this all bits to be 1, which is 255. Let's subtract only 16. So 255 minus 16, we will be getting 239. So we can take any approach in order to solve this. And that's it. We saw the conversion of the binary to dotted decimal notation. So the answer for example 1 is 129.11.75.239. Let's solve example number 2. In example number 2, we are given with the dotted decimal notation and we are required to convert it into binary notation. So the question is, convert the IPv4 address from dotted decimal to binary notation, and the IP address is given. So for solving this also, we are going to use the same methodology. So let's focus on the first octet, which is 145. How did I get this binary value? It's very simple. In order to get 145, what are the numbers we need from these set of numbers? From these 8 numbers, what are the numbers we need in order to get 145? So definitely we need 128, right? 128. So I am putting a 1 against 128. So how many it is shortage? 145 minus 128. We are shortage of 17, right? 17. So how to get 17? So 17 can be obtained using 16 and 1. So I am putting a 1 against 16 and 1. So we got 128 plus 16 plus 1, which is 145. Just fill zeros in the remaining places. So we will be getting 100100001, which is this. So the binary equivalent for 145 is 1001001. Let's move on to the second octet, which is 14. How can we get 14 with the help of these 8 numbers? So 14 can be obtained with the help of 8. So we need 8 definitely. And how many is shortage? 14 minus 8 is 6. So we are 6 shortage. We are putting 1 against 4 and 2 because 4 plus 2 is 6. So 8 plus 4 plus 2 is 14. So we are putting 1 against 8, 4 and 2. So the binary equivalent for 14 is 0000 11110. That is this 0000 And let's move on to the third octet, which is 6. How can we get 6? It's simply 4 plus 2, right? So just use 4 plus 2 and fill zeros in the remaining places. So we will be getting this as the binary equivalent for the decimal 6. Let's move on to the last octet, which is 8. So we can get 8 with the help of this place only. So we are putting 1 against 8 and we don't want other positions. So just fill zeros in other position. So we will be getting 0000100. So we are adopting this strategy and converting the dotted decimal to binary and binary to dotted decimal. Some may have a question in their mind. For example, let's take this number 14. For 14, can we get another possibility? No, there can be only one possibility when we go with this approach, because we can't put a 1 against 16. We need only 14, right? So we can't use 16. We need only 14. So 14 can be obtained with only one possibility using this approach. And what's the final answer? The final answer for this question is this. Before we conclude, let's see the homework question. We have 2 questions. Question number 1. Change the following IP address from dotted decimal notation to binary notation. And we are given with the IPv4 address 208.34.54.12. And question number 2. Change the following IP address from binary notation to dotted decimal notation. And we are given with the binary notation. Pause this video for a while and solve this homework problem and post your answers in the comment section. I hope now you know the conversion of IPv4 address from dotted decimal to binary and vice versa. I hope you guys enjoyed the lecture and thank you for watching.